Imagine a world covered in ice. A world where glaciers stretched for thousands of miles. Where temperatures plummeted far below anything we experience today. This was Earth during the Ice Age. A period so transformative that it shaped the very landscape we walk on today. Welcome to our journey through time. A journey to understand one of the most dramatic chapters in our planet's history. The Ice Age. But before we begin, we need to understand something important. Something that might surprise you. We are actually living in an ice age right now. Yes, you heard that correctly. We are in an ice age at this very moment. You see, an ice age isn't just about the entire planet being frozen. An ice age is defined as any period when ice sheets cover large portions of Earth's surface. And right now, we have massive ice sheets in Antarctica and Greenland. This means we're technically in what scientists call the late Cenozoic Ice Age. An ice age that began about 34 million years ago. And it continues to this day. Within these long ice ages, there are cycles. Periods when the ice advances and retreats. When glaciers grow and shrink. Scientists call the cold periods glacials. And the warmer periods interglacials. Right now, we're living in an interglacial period. A warm phase that began about 11,700 years ago. We call this period the Holocene. But when most people think of the Ice Age, they're thinking of something specific. They're thinking of the last glacial period. The time when ice sheets covered much of North America, Europe, and Asia. When woolly mammoths roamed frozen landscapes. When early humans struggled to survive in a world dominated by ice. That period peaked about 20,000 years ago. And it's the Ice Age we'll focus on in this documentary. Let's travel back in time. Back to the Pleistocene epoch, a time that began 2.6 million years ago. Picture yourself standing in what is now New York City. But there's no city here. No skyscrapers. No streets or buildings. Instead, you're standing beneath a wall of ice. A glacier so massive it towers above you like a frozen mountain. This ice sheet is more than 2 miles thick. That's over 12,000 feet of solid ice. And it stretches as far as the eye can see. To the north, south, east, and west. All you can see is ice. This wasn't just happening in North America. In Europe, ice sheets covered Scandinavia, Russia, and much of Britain. The Alps were buried under thick glaciers. In Asia, ice spread across Siberia. Even parts of South America were covered in ice. The world had become a frozen realm. But it wasn't a quick freeze. This transformation took thousands of years. The ice advanced slowly, relentlessly. Year after year, century after century. Grinding its way across the landscape. Reshaping continents. Creating the world we know today. Now let's talk about what caused this dramatic climate shift. Why did Earth plunge into an ice age? The answer is complex, fascinating, and still being studied by scientists today. There isn't just one cause. It's a combination of factors working together. Like instruments in an orchestra, each playing their part. The first major factor is Earth's position in space. Our planet's orbit around the sun isn't perfectly circular. It changes over time. Sometimes it's more circular, sometimes more elliptical. This affects how much sunlight Earth receives. Scientists call these changes Milankovitch cycles, named after Serbian scientist Milutin Milankovic. He discovered that Earth goes through predictable orbital changes. These cycles occur over tens of thousands of years. One cycle is about the shape of Earth's orbit, called eccentricity. It takes about 100,000 years to complete. Another cycle involves the tilt of Earth's axis, called obliquity. This cycle takes about 41,000 years. And finally, there's the wobble of Earth's axis, called precession. This cycle takes about 23,000 years. When these cycles align in certain ways, they can trigger ice ages. They affect how much sunlight reaches different parts of Earth, particularly in the higher latitudes near the poles. When the northern hemisphere receives less summer sunlight, snow doesn't melt completely. Year after year, the snow accumulates, layer upon layer. Eventually, the weight of the snow compresses the lower layers into ice, and a glacier is born. But orbital cycles alone aren't enough to create an ice age. There's another crucial factor, the position of continents. You see, Earth's continents aren't fixed in place. They drift slowly across the planet's surface, a process called plate tectonics. Over millions of years, continents move, collide, and separate, and their positions dramatically affect Earth's climate. About 3 million years ago, something significant happened. The Isthmus of Panama formed. This narrow land bridge connected North and South America. Before this, warm tropical water flowed freely between the Atlantic and Pacific Oceans. But the new land bridge blocked this flow. Ocean currents were redirected. The Gulf Stream, a warm current, was strengthened. It carried warm, moist air toward Europe. But it also meant more moisture was available to fall as snow. Snow that could accumulate in the far north. Snow that could become ice. Today, we have a continent sitting over the South Pole, Antarctica. We have an almost landlocked ocean over the North Pole, the Arctic. This arrangement is perfect for sustaining ice sheets. Cold water stays trapped near the poles, unable to mix freely with warmer tropical waters. This keeps temperatures low enough for ice to persist year-round. Another factor scientists have identified is atmospheric composition, particularly the levels of carbon dioxide and methane. These greenhouse gases trap heat in Earth's atmosphere. When their levels drop, Earth cools. When their levels rise, Earth warms. During ice ages, carbon dioxide levels are significantly lower. But what causes these levels to change? One answer lies in the weathering of rocks. When rain falls, it combines with carbon dioxide in the air to form a weak acid. This acid weathers rocks, breaking them down. The carbon is then washed into the ocean, where it's eventually locked away in sediments on the seafloor. About 50 million years ago, something dramatic happened. The Indian subcontinent collided with Asia. This collision created the Himalayas, the highest mountain range on Earth. These towering peaks increased rainfall patterns. More rain meant more weathering. More weathering meant more carbon dioxide removed from the atmosphere. Over millions of years, this helped cool the planet. Some scientists believe the Himalayas played a crucial role in triggering our current ice age. Volcanic activity also affects Earth's climate. Large volcanic eruptions can inject massive amounts of particles into the atmosphere. These particles block sunlight, cooling the planet temporarily. A single large eruption can cool Earth for years. Multiple eruptions can have even longer lasting effects. Even asteroids and comets have played a role. When large space rocks impact Earth, they throw enormous amounts of dust into the atmosphere. This dust blocks sunlight, causing global cooling. The most famous example is the asteroid that killed the dinosaurs. 66 million years ago, an asteroid struck what is now Mexico. The impact caused massive climate disruption. But that's a different story from a different age. So we have orbital cycles, continental positions, greenhouse gases, mountain building, volcanic activity. All these factors working together over millions of years, creating the conditions for ice ages to begin and end. It's a delicate balance, a complex dance of Earth systems interacting with each other, and with the sun and with space itself. Now let's look at what happens when an ice age takes hold. How does it transform our planet? First, the ice itself. At the peak of the last glacial period, ice sheets covered about 30% of Earth's land surface. Today, ice covers about 10%. That's a massive difference. The ice sheets were truly enormous. In North America, the Laurentide ice sheet stretched from the Arctic Ocean down to what is now New York and the Midwest. It covered all of Canada and much of the northern United States. In some places, the ice was more than 2 miles thick. Imagine the weight of all that ice. It was so heavy it actually pushed the Earth's crust downward, depressing the land beneath it. Even today, thousands of years after the ice melted, the land is still slowly rising back up. A process called postglacial rebound. In Scandinavia, the land is still rising by about 8 to 9 millimeters per year. That's nearly 1 meter every 100 years. The advancing glaciers were powerful forces of nature. As they moved, they scraped and scoured the landscape, picking up rocks and soil, carving out valleys, smoothing mountains, creating the landscapes we see today. The Great Lakes in North America were carved by glaciers. These massive depressions were gouged out by the weight and movement of ice. When the glaciers melted, they filled with water. creating the largest group of freshwater lakes on Earth. In Europe, the glaciers created the fjords of Norway. These deep, narrow inlets of the sea, surrounded by steep cliffs. They were once valleys carved by glaciers. When the ice melted and sea levels rose, the ocean flooded these valleys, creating the dramatic landscapes we see today. The ice also left behind other telltale signs. As glaciers retreat, they drop the rocks and soil they've been carrying, creating features called moraines. These ridges of sediment mark the former extent of glaciers. Long Island in New York is actually a terminal moraine, a ridge of debris left behind by the retreating ice sheet. Cape Cod, Martha's Vineyard, and Nantucket are also glacial features, created by the Ice Age that ended thousands of years ago. But the Ice Age didn't just affect the land. It had a profound impact on the oceans too. You see, when water freezes into ice sheets, it has to come from somewhere. And that somewhere is the ocean. As ice sheets grew, sea levels dropped. And they didn't just drop a little. At the peak of the last glacial period, sea levels were about 400 feet lower than today. That's over 120 meters. 400 feet. Let that sink in for a moment. If you stood on a beach during the Ice Age, you'd have to walk for miles to reach the ocean. The coastlines looked completely different. This drop in sea level had enormous consequences. It exposed vast areas of land that are now underwater. Land bridges appeared between continents. One of the most famous is the Bering Land Bridge. During the Ice Age, a wide stretch of land connected Asia and North America, where today there's only the narrow Bering Strait. This land bridge, called Beringia, was crucial for human history. It's how the first people migrated from Asia to the Americas, following herds of animals across this frozen landscape, spreading throughout the Americas over thousands of years. In Europe, Britain was connected to the mainland. You could walk from France to England without getting your feet wet. The English Channel didn't exist as we know it today. Instead, there was a river valley. Rivers that now flow into the sea carved much deeper valleys, because the sea level was so much lower. The lower sea levels also exposed continental shelves. Vast areas of shallow seafloor became dry land. In Southeast Asia, many islands were connected, creating a landmass called Sunderland. This allowed animals and humans to spread throughout the region, without needing boats or rafts. The climate during the Ice Age was harsh. Global temperatures were about 10 degrees Fahrenheit colder on average. That's about 5 degrees Celsius. But in some regions, it was much colder. Up to 40 degrees Fahrenheit colder in some areas. That's over 20 degrees Celsius. The polar regions were brutally cold. But even places that are warm today were much cooler. The Gulf Coast of the United States, now known for its warm, humid climate, was covered in pine forests and prairie grasses during the Ice Age. The kind of vegetation you'd find in Canada today. Florida, now a tropical paradise, had a cooler, drier climate. The Sahara Desert experienced periods when it was actually wetter, with rivers and lakes appearing. The Amazon rainforest shrank significantly. Much of it was replaced by grasslands and savanna. The climate wasn't just colder, it was also drier in many places. With so much water locked up in ice, there was less moisture in the atmosphere. Less rain and snow fell in many regions. Huge dust storms swept across continents, depositing thick layers of wind-blown sediment called less. These dust deposits can be found across North America, Europe, and Asia. Evidence of the harsh, dry conditions that prevailed during the Ice Age. But not everywhere was covered in ice. Large areas remained ice-free even during the coldest periods. These regions are called refugia, places where life could survive, adapt, and wait out the Ice Age. In North America, areas south of the ice sheets remained habitable. Parts of Alaska and the Yukon were actually ice-free. This might seem counterintuitive, but it's true. The climate there was too dry for ice sheets to form. Instead, there was a cold, dry grassland called the Mammoth Steppe. This Mammoth Steppe was a unique ecosystem, unlike anything that exists today. It stretched from Spain across Europe and Asia, through Siberia and into North America. A vast, unbroken grassland supporting enormous herds of animals. And that brings us to the creatures that lived during the Ice Age. The megafauna. The giants of the frozen world. When we think of Ice Age animals, certain creatures come to mind immediately. The woolly mammoth with its thick fur and massive curved tusks. The saber-toothed cat with its enormous canine teeth. The giant ground sloth as tall as a giraffe. The woolly rhinoceros with its 2 horns and thick coat. Cave bears, cave lions, dire wolves. Gigantic beavers, massive armadillo-like creatures called glyptodonts. These were the megafauna of the Ice Age. And they were truly spectacular. Let's focus on the most iconic of all, the woolly mammoth. These magnificent creatures roamed the earth for hundreds of thousands of years. They first appeared about 800,000 years ago, evolving from an earlier species called the steppe mammoth. By 300,000 years ago, they had spread across Europe, Asia, and North America. Millions of woolly mammoths grazed the grasslands of the northern hemisphere. Woolly mammoths were similar in size to modern elephants. Males stood about 10 to 12 feet tall at the shoulder. That's about 3 to 3.5 meters. They weighed between 6 and 8 tons. Females were slightly smaller, about 7 to 8 feet tall. But what made them distinctive was their adaptation to the cold. They were covered in 2 layers of fur. The outer layer was long and shaggy, reaching up to 20 inches in length. Beneath this was a shorter, denser undercoat. This double layer provided excellent insulation against the bitter cold. They could survive in temperatures as low as -58 degrees Fahrenheit. That's -50 degrees Celsius. Their ears were small, much smaller than modern elephants. This helped reduce heat loss. Large ears lose too much body heat in cold climates. So evolution favored smaller ears for these Ice Age giants. They had a distinctive hump on their back. Scientists believe this was a fat reserve, similar to a camel's hump. During harsh winters when food was scarce, mammoths could live off this stored energy. It was a crucial adaptation for survival in unpredictable conditions. And then there were their tusks. Magnificent curved tusks that could grow up to 15 feet long. These tusks weren't just for show. Mammoths used them to dig through snow to reach vegetation, to strip bark from trees, to fight off predators, and males used them to compete with each other during mating season. The largest tusks ever found were over 16 feet long. An incredible testament to these animals' size and power. Woolly mammoths were herbivores. They fed on grasses, shrubs, and other plants. Scientists have studied the stomach contents of frozen mammoth carcasses. Remarkably well-preserved specimens found in Siberian permafrost. These studies reveal that mammoths ate a variety of plants. Grasses, sedges, flowering plants, and even some mosses. Recent research suggests that flowering plants, called forbs, were particularly important in their diet. Plants like sagebrush, yarrow, and other broad-leafed vegetation. These plants provided essential protein and nutrients, more than grasses alone could provide. Mammoths were social animals, much like modern elephants. Females and their young traveled together in family groups. These herds typically consisted of about 15 individuals, led by an older, experienced female called a matriarch. Young males would leave the herd when they reached about 10 years of age. After that, they lived more solitary lives or formed small bachelor groups. Mammoths gave birth to a single calf after a pregnancy lasting about 22 months. That's nearly 2 years of gestation, the longest of any land animal. Newborn calves weighed about 200 pounds, about 90 kilograms. They were covered in a light coat of reddish-brown fur. The mother and other females in the herd cared for the calf, teaching it how to survive in the harsh Ice Age world. Young mammoths nursed for several years, learning which plants to eat, how to use their trunks, and how to find water. But mammoths weren't the only impressive creatures of the Ice Age. Let's talk about the woolly rhinoceros, another cold-adapted giant that roamed Europe and Asia. These animals were stocky and powerful, built for survival in frozen landscapes. They stood about 6 feet tall at the shoulder and weighed up to 3 tons. Like mammoths, they had thick fur covering their bodies, protection against the relentless cold. But their most distinctive feature was their 2 horns. The front horn could grow up to 3 feet long, flattened from side to side, perfect for sweeping snow away from vegetation. Woolly rhinos were also herbivores, feeding on grasses and shrubs. They lived solitary lives unlike the social mammoths, only coming together during mating season. Cave paintings from Ice Age humans show these magnificent creatures, giving us a glimpse of what they looked like in life. Then there were the predators. The cave lion, one of the largest lions that ever lived. Much bigger than modern lions. Males could weigh up to 700 pounds. They hunted across Europe and Asia, preying on horses, bison, and even young mammoths. Cave lions got their name because their remains are often found in caves. But they didn't live in caves year-round. They used caves for shelter during harsh weather and for raising cubs. The saber-toothed cat, or smilodon, was another fearsome predator. Though technically, it lived mainly in North and South America. Its enormous canine teeth could grow up to 7 inches long. Scientists believe these cats ambushed large prey, using their powerful forelimbs to wrestle animals to the ground, then delivering a killing bite with those incredible teeth. They preyed on large herbivores like bison, horses, and ground sloths. Speaking of ground sloths, let's discuss these peculiar creatures. Today, sloths are small tree dwellers in tropical forests. But during the Ice Age, some species of ground sloths were enormous. The Megatherium could stand up to 20 feet tall on its hind legs. It weighed up to 4 tons. Despite their size, they were herbivores, feeding on leaves and vegetation, using their long claws to pull down branches. These gentle giants roamed across the Americas, from what is now Alaska down to the southern tip of South America. Giant short-faced bears roamed North America during this time. These were the largest bears that ever lived, standing 12 feet tall on their hind legs, weighing up to 2,000 pounds. They had long legs adapted for running across open terrain. Some scientists think they were primarily scavengers. Others believe they were active hunters. Either way, they were formidable creatures, an apex predator of the Ice Age. There were also giant beavers, not just slightly larger than modern beavers, but truly gigantic. Castoroids could weigh up to 220 pounds, about 8 feet long from nose to tail. These massive rodents built dams and lodges just like their smaller relatives, but on a much grander scale. In North America, horses and camels roamed the plains. Yes, camels in North America. These weren't the humped camels we think of today. They were a different species altogether. But they were native to North America for millions of years. In fact, camels evolved in North America and later migrated to Asia. During the Ice Age, multiple species of horses and camels lived alongside mammoths and bison, creating a diverse and rich ecosystem. But all of these magnificent creatures faced a challenge that would ultimately prove fatal for many of them. Change. The Ice Age wasn't a static period. It was dynamic, with climate shifting constantly. Glacial periods alternated with warmer interglacial periods. Animals had to adapt or migrate to survive. Around 20,000 years ago, the last glacial period reached its peak. This is called the last glacial maximum. Ice sheets were at their greatest extent, sea levels at their lowest. The world was at its coldest and driest. But then something began to change. Starting about 19,000 years ago, temperatures began to rise. The ice sheet started to melt, slowly at first, then more rapidly. Over thousands of years, the glaciers retreated northward. Meltwater flowed into the oceans. Sea levels began to rise. The coastlines we know today started to take shape. This warming wasn't smooth or gradual. There were periods of rapid warming interrupted by sudden cold snaps. One of the most dramatic was the Younger Dryas period. About 12,800 years ago, just as the world was warming, temperatures suddenly plunged again. The climate returned to near-glacial conditions. This cold period lasted for about 1,000 years, from 12,800 to 11,700 years ago. Scientists aren't entirely sure what caused the Younger Dryas. One leading theory involves the collapse of ice dams in North America. As the ice sheets melted, enormous lakes formed at their edges. These glacial lakes were held back by ice dams. When the dams broke, they released catastrophic floods. Massive amounts of fresh water poured into the North Atlantic Ocean. This influx of cold, fresh water disrupted ocean currents, particularly the Gulf Stream, which carries warm water northward. When the Gulf Stream slowed or stopped, temperatures across the northern hemisphere dropped dramatically. But eventually, the warming resumed. By 11,700 years ago, the Younger Dryas ended. Temperatures rose rapidly. The ice sheets continued their retreat. In the Holocene epoch, our current warm period began. For the megafauna of the Ice Age, this period of rapid climate change was catastrophic. Their habitats were transforming faster than they could adapt. The vast grasslands they depended on were changing. As the climate warmed and became wetter, forests began to spread. Trees replaced grasses in many areas. The mammoth steppe, that unique Ice Age ecosystem, began to disappear. Recent research has revealed something fascinating about this habitat change. It wasn't just that grasslands were replaced by forests. The composition of the grasslands themselves changed. Around 10,000 years ago, a significant shift occurred. Flowering plants, those protein-rich forbs that mammoths and other megafauna relied on, began to decline. Grasses became more dominant. This was a problem for animals like woolly mammoths. Grasses alone didn't provide enough nutrients. The forbs had been a crucial source of protein and other essential nutrients. Without them, mammoths struggled to get adequate nutrition. Studies of mammoth stomach contents and preserved dung have confirmed this. DNA analysis shows that flowering plants made up a large part of their diet. When these plants declined, the mammoth's food quality decreased. They could eat the grasses, but they weren't getting the nutrition they needed. Over time, this would have weakened populations, reduced reproductive success, made them more vulnerable to other threats. But vegetation change wasn't the only challenge these animals faced. There was another factor, one that would prove particularly devastating. Humans. Modern humans, Homo sapiens, evolved in Africa. For most of our history, we were confined to Africa and parts of the Middle East. But around 70,000 years ago, we began to spread, migrating into Asia, then Europe, eventually reaching Australia. And finally, the Americas. Humans entered Europe between 40,000 and 30,000 years ago. They encountered a landscape full of megafauna: mammoths, woolly rhinos, cave bears, and lions. These animals had never encountered human hunters before. They had no instinctive fear of us. And humans brought something unprecedented to the Ice Age world: advanced hunting technology. By this time, humans had developed sophisticated tools: stone-tipped spears, atlatls for throwing spears with greater force and accuracy. Later, they would invent the bow and arrow. They had fire, which they used for warmth, cooking, and perhaps even to drive game. They hunted cooperatively in organized groups, using strategies and tactics honed over generations. They could communicate complex plans through language, something no other predator could do. Humans didn't need to hunt mammoths every day. They didn't need to kill hundreds or thousands of them. Mathematical models have shown that even very low levels of hunting pressure could have driven mammoths to extinction. If each human killed just one mammoth every 3 years, the species would disappear. In some estimates, even lower levels of hunting, one mammoth per human every 200 years, might have been enough. When you combine this with the stress from habitat loss and climate change, you get a recipe for extinction. Evidence of human hunting of megafauna has been found across multiple continents. Mammoth bones with cut marks from stone tools, spear points embedded in mammoth skeletons, butchery sites where multiple animals were processed. In North America, distinctive stone tools called Clovis points are often found with mammoth remains. The Clovis people entered North America about 13,000 years ago. They spread rapidly across the continent, following the megafauna, hunting them as they went. Recent studies of a young boy's remains from Montana, known as Anzac 1, have revealed fascinating details. This child lived about 12,600 years ago. Analysis of his bones showed that mammoths made up about 40% of his mother's diet. This suggests that Clovis people were specialized mammoth hunters, focusing on these large animals as a primary food source. The high-protein, high-fat meat from a single mammoth could feed a group for weeks. This made them valuable targets for human hunters. But we shouldn't think of early humans as the sole villains in this story. They were simply doing what they needed to survive, hunting for food, shelter, and materials. Mammoth bones were used to build structures. Mammoth ivory was carved into tools and art. Mammoth hides provided warmth. Early humans were incredibly resourceful, using every part of the animals they hunted. The extinction of the megafauna wasn't instantaneous. It happened over thousands of years. Different species disappeared at different times and in different places. In Europe, woolly rhinos went extinct around 10,000 years ago. Cave bears disappeared around the same time. In North America, most megafauna disappeared between 13,000 and 11,000 years ago. Mammoths, mastodons, giant ground sloths, saber-toothed cats, horses, and camels all vanished from the continent. But the story isn't quite over for the woolly mammoths. While most populations died out around 10,000 years ago, some survived much longer. On isolated islands off the coast of Siberia and Alaska, small populations persisted. On St. Paul Island in Alaska, mammoths survived until about 5,600 years ago. On Wrangel Island in the Arctic Ocean north of Siberia, mammoths survived even longer. Until about 4,000 years ago. That's roughly 3,700 BCE. To put that in perspective, the Great Pyramids of Giza were built around 2,560 BCE. Woolly mammoths were still alive when the ancient Egyptians were building their pyramids. It's a remarkable thought. These island populations were small and isolated, cut off from the mainland when sea levels rose at the end of the Ice Age. They had limited genetic diversity. Studies show that they suffered from inbreeding. Genetic problems accumulated over generations. Eventually, these populations became too small and too weak to survive. A combination of inbreeding, environmental stress, and possibly human hunting finally drove them to extinction. The last mammoths on Wrangel Island marked the final end of a species that had thrived for hundreds of thousands of years. The extinction of the megafauna had profound effects on ecosystems. These large animals played crucial roles in their environments. Mammoths, for instance, were ecosystem engineers. As they fed, they knocked down trees, cleared brush, and maintained grasslands. Their dung fertilized the soil and spread seeds across vast distances. They created pathways through forests that other animals used. When they disappeared, the ecosystems they shaped began to change. In Siberia, the mammoth steppe began to transform. Without large herbivores maintaining it, the grasslands gave way to mossy tundra and eventually forest. The diverse, productive ecosystem of the Ice Age was replaced by less diverse habitats. Some scientists believe that the extinction of mammoths actually accelerated climate change. The vegetation changes that followed altered how much sunlight was reflected or absorbed by the land's surface, affecting regional and potentially global climate. There's even an effort underway today to restore the mammoth steppe ecosystem. In northeastern Siberia, scientists have created Pleistocene Park. They've introduced large herbivores like horses, bison, and musk oxen. The goal is to see if these animals can recreate the grassland ecosystem of the Ice Age. Early results are promising. The animals are trampling moss, fertilizing the soil, and encouraging grass growth. It's a fascinating experiment in rewilding and ecological restoration. But the loss of the megafauna meant more than just ecological changes. It represented a transformation of the entire planet. The world became a quieter place, less dramatic. The giants that had dominated landscapes for millions of years were gone, and humans became the dominant large animal on most continents. For early humans, the end of the Ice Age brought both challenges and opportunities. As the climate warmed and the ice retreated, new lands opened up. Forests spread, providing new resources. Rivers and lakes formed, offering fresh water and fish. But the megafauna they had relied on were disappearing. Humans had to adapt their hunting strategies. They began focusing on smaller game, fish, and birds. They gathered more plants, seeds, and nuts. Some groups began to experiment with something entirely new, controlling the plants and animals they depended on. In other words, agriculture. The transition from the Ice Age to the Holocene marked the beginning of the Neolithic Revolution. The agricultural revolution. Around 10,000 years ago, in various parts of the world, humans began to domesticate plants and animals. In the Fertile Crescent of the Middle East, they cultivated wheat, barley, and legumes. They domesticated sheep, goats, cattle, and pigs. In China, they cultivated rice and millet. In Mesoamerica, they domesticated corn, beans, and squash. In the Andes, they cultivated potatoes and quinoa and domesticated llamas and alpacas. This shift from hunting and gathering to farming was revolutionary. It allowed human populations to grow dramatically. Permanent settlements developed. Villages, then towns, then cities. Civilization as we know it began to emerge. Writing, mathematics, complex social structures, trade networks. All of these developments were made possible by agriculture. And agriculture was made possible, in part, by the end of the Ice Age and the extinction of the megafauna. But what about the ice itself? The massive ice sheets that covered so much of the planet. They continued to melt throughout the early Holocene. The Laurentide ice sheet in North America persisted until about 7,000 years ago. As it melted, it created enormous glacial lakes. Lake Agassiz, which covered parts of what are now Manitoba, Ontario, Saskatchewan, North Dakota, and Minnesota, was larger than all of the modern Great Lakes combined. When ice dams holding back these lakes failed, they released catastrophic floods. The channeled scablins in Washington state were carved by one such flood. Glacial Lake Missoula, held back by an ice dam, suddenly burst through, releasing water equivalent to 50 times the flow of the Amazon River. The flood scoured the landscape, creating a bizarre terrain of channels, canyons, and waterfalls, all in a matter of days or weeks. It's one of the most dramatic examples of the power of Ice Age floods. Similar floods occurred in other regions. In Siberia, in Northern Europe, in Canada. These megafloods reshaped landscapes, carved valleys, and deposited enormous amounts of sediment. They even affected ocean currents and global climate. The sudden influx of fresh water into the oceans altered salinity levels, disrupting the circulation patterns that regulate Earth's temperature. Today, the only remnants of the Great Ice Age ice sheets are in Greenland and Antarctica. The Greenland ice sheet covers about 660,000 square miles. If it melted completely, sea levels would rise about 23 feet, over 7 meters. The Antarctic ice sheet is even larger, covering about 5.5 million square miles. If it melted, sea levels would rise about 200 feet, over 60 meters. These ice sheets are the reason we say we're still technically in an ice age. As long as they persist, we're in an ice age by definition. But these ice sheets are now threatened. Human-caused climate change is warming the planet at an unprecedented rate. The ice is melting faster than it has in thousands of years. If current trends continue, these ancient ice sheets could disappear within centuries, causing catastrophic sea level rise, flooding coastal cities around the world, displacing hundreds of millions of people. It's a sobering reminder that the Ice Age isn't just ancient history. It's connected to our present and our future. Let's step back and look at the bigger picture. The Ice Age we've been discussing, the Quaternary Ice Age, is just the most recent one. Earth has experienced at least 5 major ice ages throughout its history, some lasting tens of millions of years, each one dramatically reshaping the planet. The earliest known ice age occurred during the Huronian period, between 2.4 and 2.1 billion years ago. Yes, billion with a B. This was during the Precambrian, long before complex life existed. Earth was a very different place then. The atmosphere had little oxygen. The only life forms were single-celled microorganisms. Yet somehow, conditions aligned to create global glaciation. Some scientists believe Earth might have been completely covered in ice during this period, a phenomenon called snowball Earth. Imagine the entire planet frozen solid from pole to pole, ice covering even the tropical oceans. It's difficult to fathom, but evidence suggests it may have happened. The next major ice age was the Cryogenian, between 850 and 635 million years ago. This ice age may have been the most severe in Earth's history. Again, evidence points to possible snowball Earth conditions. ice sheets extending all the way to the equator. Life barely clinging on in pockets of open water or in the deep oceans. Yet life persisted. And when this ice age ended, something remarkable happened. The Cambrian explosion, a period of rapid evolutionary diversification. In just a few tens of millions of years, most of the major animal groups we know today appeared in the fossil record. Some scientists think the harsh conditions of the ice age, followed by rapid warming, actually spurred evolution, forcing life to adapt, diversify, and innovate. After the Cryogenian came the Andean-Saharan Ice Age, between 460 and 430 million years ago. During the Ordovician and Silurian periods, ice sheets covered parts of what is now Africa and South America. These continents were positioned near the South Pole at that time. This ice age coincided with major changes in life on Earth. Plants were just beginning to colonize the land. The first forests were starting to grow, and this vegetation would eventually change Earth's climate forever. Then came the Karoo Ice Age, also called the Permo-Carboniferous Ice Age, between 360 and 260 million years ago. This was during the Carboniferous and Permian periods, the time when vast coal deposits formed. Dense tropical forests covered much of the planet. When these forests died, their organic matter was buried and compressed. Over millions of years, it turned into coal. The coal we burn today for energy, releasing carbon dioxide that had been locked away for hundreds of millions of years. During this time, ice sheets waxed and waned over what is now the southern continents. Life on Earth included giant insects, early reptiles, and amphibians. The climate cycled between glacial and interglacial periods, much like our current ice age. And finally, we come to the late Cenozoic Ice Age. Our current ice age, which began about 34 million years ago. This is the ice age we're still living in today. It began when Antarctica started to freeze. The continent had drifted to the South Pole and become isolated. Ocean currents changed, and a circular current formed around Antarctica, the Antarctic Circumpolar Current. This current isolated Antarctica from warmer waters. Temperatures dropped and ice began to accumulate. By about 14 million years ago, Antarctica was covered in a permanent ice sheet. But ice in the northern hemisphere is much more recent. The Arctic ice cap only formed about 2.6 million years ago. This marks the beginning of the Quaternary period and the Pleistocene epoch, the time of the great northern hemisphere ice sheets, the time of mammoths and saber-toothed cats, the time when humans evolved and spread across the planet. During the past 2.6 million years, Earth has cycled between glacial and interglacial periods. At least a dozen major glaciations have occurred, each one lasting tens of thousands of years, separated by warmer interglacial periods lasting 10 to 30,000 years. We're currently in one of these warm interglacials, the Holocene, which has lasted about 11,700 years so far. Scientists can reconstruct these climate cycles using several methods. One of the most powerful is analyzing ice cores from Greenland and Antarctica. Drilling deep into the ice sheets, scientists can extract cores going back hundreds of thousands of years. Each layer of ice represents a year of snowfall. Trapped in the ice are tiny bubbles of ancient air. By analyzing these bubbles, scientists can measure atmospheric carbon dioxide levels from the past. They can also measure isotope ratios that reveal temperature. These ice cores provide an incredibly detailed climate record. Another method is analyzing sediment cores from the ocean floor. As microscopic organisms like foraminifera die, their shells sink to the seafloor. These shells contain oxygen isotopes that reflect the ocean's temperature and ice volume. By extracting long cores of sediment, scientists can reconstruct climate going back millions of years. They've identified more than 50 different glacial-interglacial cycles in the past few million years. Each one is assigned a number in the marine isotope stage system. We're currently in MIS-1, the Holocene. The last glacial period was MIS-2, and so on going back through time. These records reveal patterns. Glacial-interglacial cycles follow a rhythm linked to Earth's orbital variations. The Milankovitch cycles we discussed earlier. For the past million years, the dominant cycle has been about 100,000 years long. Long glacial periods lasting 70 to 90,000 years, followed by short, warm interglacials lasting 10 to 30,000 years. The transition from glacial to interglacial is often rapid. Temperatures can rise dramatically in just a few thousand years, sometimes even faster. But here's something important to understand. These natural climate cycles happen slowly, over thousands or tens of thousands of years. Life has time to adapt, migrate, and evolve. What we're experiencing now is different. Human-caused climate change is happening on a timescale of decades, not millennia. This is unprecedented in recent Earth history. Since the Industrial Revolution began around 1800, humans have been burning fossil fuels on a massive scale. Coal, oil, and natural gas. These fuels are the remains of ancient plants and animals, buried and transformed over hundreds of millions of years. When we burn them, we release carbon dioxide that had been locked away. We're essentially revering millions of years of carbon storage in just a few centuries. Atmospheric carbon dioxide levels are now higher than they've been in at least 3 million years. Higher than at any point during the Quaternary Ice Age. The last time CO2 levels were this high, global temperatures were significantly warmer. Sea levels were much higher. The Arctic had no ice, and forests grew in places that are now tundra. We're currently warming the planet about 10 times faster than the natural warming that ended the last ice age. Some estimates suggest even faster rates of change. This rapid warming is already having dramatic effects. Glaciers around the world are retreating. The Arctic sea ice is shrinking. The Greenland ice sheet is melting faster than at any point in the past 12,000 years. Parts of the Antarctic ice sheet are becoming unstable. Permafrost in the Arctic is thawing, releasing methane, an even more potent greenhouse gas. Sea levels are rising, about 8 inches since 1800, and the rate is accelerating. If current trends continue, we could see several feet of sea level rise by the end of this century, and many more feet in the coming centuries. Coastal cities like New York, Miami, Shanghai, and Mumbai face potential flooding. Low-lying island nations could become uninhabitable. Hundreds of millions of people live in areas that could be affected. The effects go beyond sea level rise. Weather patterns are changing. Some regions are experiencing more intense droughts. Others are seeing more severe flooding. Hurricanes and typhoons are becoming more powerful. Heat waves are more frequent and more intense. Wildfires are more common and more destructive. Ecosystems are struggling to adapt. Species that thrived during the stable Holocene climate are facing unprecedented stress. Many are migrating to cooler regions, to higher latitudes or higher elevations. But some can't move fast enough. Habitat loss, changing precipitation patterns, and temperature stress are pushing many species toward extinction. We're in the midst of what some scientists call the sixth mass extinction. The first mass extinction caused by a single species, us. But it's not all doom and gloom. Understanding the Ice Age and Earth's climate history gives us important insights. It shows us how interconnected Earth systems are. How changes in one part of the system affect everything else. It teaches us about resilience and adaptation. Life has survived multiple ice ages, mass extinctions, and dramatic climate changes. It's incredibly resilient, but it needs time to adapt. We also have tools our ancestors didn't have. We understand what's happening and why. We have the technology to transition to clean energy sources. Solar, wind, geothermal, nuclear power. We can develop sustainable agriculture and forestry practices. We can protect and restore ecosystems. We can reduce our carbon footprint and help stabilize the climate. Many countries and communities are already taking action. Renewable energy is growing rapidly. Electric vehicles are becoming more common. Reforestation projects are underway around the world. New technologies are being developed to capture and store carbon. International agreements like the Paris Agreement aim to limit warming. It's a massive challenge, but not an insurmountable one. The Ice Age also teaches us about human resilience and ingenuity. Our ancestors survived incredibly harsh conditions. They adapted to a changing world. They developed new tools, new strategies, new ways of living. They spread to every continent except Antarctica. They thrived in deserts, forests, grasslands, and Arctic tundra. Early humans during the Ice Age were incredibly resourceful. They used every part of the animals they hunted. They built shelters from mammoth bones and hides. They created sophisticated tools from stone, bone, and antler. They developed art, creating cave paintings that still amaze us today. Paintings of the animals they hunted, the landscapes they lived in. These artworks, some over 30,000 years old, connect us to our ancestors. They remind us that humans have always been creative, curious, and adaptable. They also developed complex social structures. Cooperation was essential for survival in the harsh Ice Age world. Hunting large animals required coordination and teamwork. Sharing food and resources helped groups survive lean times. Caring for the sick, elderly, and young strengthened communities. These behaviors laid the foundation for human civilization. Language was crucial too. The ability to communicate complex ideas, to pass knowledge from one generation to the next. To plan, strategize, and tell stories. Language allowed humans to accumulate knowledge over time, each generation building on what came before. This cultural evolution, alongside biological evolution, made humans uniquely successful. The Ice Age was also a time of human genetic evolution. Natural selection shaped our ancestors in various ways. Adaptations to cold climates, to different diets, to high altitudes. The diversity we see in human populations today reflects our Ice Age heritage. Different groups adapted to different environments as they spread across the globe. Genetic studies have revealed fascinating details about Ice Age humans. We now know that Homo sapiens interbred with other human species. Neanderthals, who lived in Europe and Asia, interbred with modern humans. Today, people of European and Asian descent carry about 2% Neanderthal DNA. We also interbred with Denisovans, another extinct human species. People of Melanesian and Australian Aboriginal descent carry Denisovan DNA. These ancient encounters left a lasting genetic legacy. Some of these ancient genes actually helped us adapt to new environments. For instance, some Neanderthal genes affect immune system function and skin pigmentation. Denisovan genes help Tibetans adapt to high altitude. The Ice Age shaped not just human biology but human culture and psychology. The experience of surviving in harsh, unpredictable environments. The need for cooperation and innovation. The importance of planning for the future. These challenges shaped how we think, how we organize societies, how we relate to nature. In many ways, we're still Ice Age creatures living in a modern world. As we look to the future, the lessons of the Ice Age are more relevant than ever. We're living through a period of rapid climate change. But unlike the natural cycles of the past, this change is driven by human activity. And unlike our Ice Age ancestors, we have the knowledge and tools to address it. The question is, will we? Will we take the necessary steps to stabilize the climate? Will we protect the ecosystems and species that share this planet with us? Will we learn from the past to build a sustainable future? These are the challenges we face, not as individuals but as a global community. The Ice Age reminds us that Earth's climate is not static. It's dynamic, always changing. For billions of years, our planet has cycled through warm periods and ice ages. Life has adapted, evolved, and thrived through all of these changes. But the key word is time. Natural climate changes happen over thousands or millions of years. The current change is happening over decades. And that's the real danger. The ice cores from Antarctica contain 800,000 years of climate history. They show us that carbon dioxide levels and temperature are closely linked. When CO2 rises, temperature rises. When CO2 falls, temperature falls. It's a clear, undeniable relationship. And right now, CO2 levels are shooting up faster than ever recorded in those ice cores. We're conducting a global experiment with our planet's climate. And we're already seeing the results. But there's also hope in understanding the Ice Age. It shows us that Earth is resilient. that life is adaptable, that dramatic changes are possible. The world can transform from ice to warmth, from barren to lush, if we give it time and protect what remains. The extinction of the megafauna teaches us about the consequences of our actions. The loss of woolly mammoths, saber-toothed cats, and giant ground sloths. These magnificent creatures that thrived for millennia, gone in just a few thousand years. We don't want to repeat that mistake on a larger scale. We don't want to be remembered as the species that destroyed Earth's biodiversity. Instead, we can be the species that learned from the past, that understood our impact and chose to change course, that protected the incredible diversity of life on Earth, that built a sustainable relationship with our planet. The Ice Age is not just ancient history. It's written in the landscapes around us. The valleys carved by glaciers, the lakes formed by melting ice, the fossils of extinct megafauna, the genetic legacy in our own DNA. Every time you look at the Great Lakes, you're seeing the Ice Age. Every time you visit a fjord in Norway or a glacial valley in the Alps, you're seeing the Ice Age. The fertile soils of the American Midwest, deposited by glaciers. The rocky coast of New England, scraped and shaped by ice. These are all testaments to the power and reach of the Ice Age. Museums around the world display Ice Age fossils, reconstructed skeletons of mammoths and mastodons, cave paintings from Ice Age humans, stone tools that helped our ancestors survive. These artifacts connect us to a time that seems impossibly remote. Yet it's not that long ago, just a few hundred human lifetimes. If each generation lived to be 80 years old, it would take only about 150 generations to reach back to the end of the Ice Age. That's a long time for an individual, but a blink of an eye in geological terms. And who knows? Perhaps we're just in another interglacial. Perhaps in tens of thousands of years, the ice will advance again. The glaciers will return to cover Canada and Scandinavia. The mammoths, of course, won't be there. But life will adapt to whatever comes. It always has. Or perhaps human activity will prevent the next ice age. Some scientists think that by adding so much carbon dioxide to the atmosphere, we've actually delayed or prevented the next glacial period. We may have inadvertently extended our current warm period for thousands of years or more. It's an ironic thought. We're changing the climate so much that we're interrupting the natural cycle of ice ages. But for now, we're in the Holocene, a warm, stable interglacial that has lasted over 10,000 years. The most stable climate period humans have ever known. The climate that allowed agriculture to develop, that allowed civilizations to rise, that allowed human population to grow from a few million to over 8 billion today. We owe a lot to the stable Holocene climate, and we're risking that stability. By warming the planet too quickly, we're moving into uncharted territory. A climate state unlike anything humans have experienced. Warmer than any time in our species' history. But with knowledge comes responsibility. We understand what's happening. We know why it's happening. And we have the ability to do something about it. The Ice Age, with all its challenges and changes, ultimately helped make us who we are. It shaped our evolution, our migrations, our cultures. It tested our ancestors and forced them to innovate and adapt. And they succeeded. They survived the harshest conditions and emerged stronger. Now it's our turn to face a challenge. Not ice advancing, but ice retreating. Not cooling, but warming. Not natural, but caused by us. And just like our Ice Age ancestors, we have the intelligence and creativity to adapt, to find solutions, to build a better future. The story of the Ice Age is ultimately a story about change, about how Earth systems interact and evolve, about how life responds to challenge, about resilience, adaptation, and survival. It's a story that connects deep time with the present day. That links the movements of continents to the lives of mammoths. That shows how the position of Earth in space affects the ice on its surface, and how that ice, in turn, affects every living thing on the planet. It's a story of loss and transformation, of magnificent creatures that no longer walk the Earth, of landscapes that were once unimaginably different, of humans taking their first steps toward becoming the dominant species on the planet. And it's a story that isn't over. We're still living in the Ice Age technically, still experiencing its lingering effects, still shaped by the forces that created it. As we face the challenges of the 21st century, the Ice Age offers both warnings and inspiration. Warnings about the fragility of ecosystems and the consequences of rapid change. Inspiration about the power of adaptation and the resilience of life. The ice may have retreated, but its legacy remains. In the rocks beneath our feet, in the genes in our cells, in the stories we tell, and in the lessons we carry forward. The Ice Age explained, not just as a period of cold and ice, but as a dynamic, complex, fascinating chapter in Earth's history. A chapter that shaped our world and made us who we are. Thank you for joining us on this journey through time, through the frozen landscapes of the past, through the lives of creatures long extinct, through the challenges and triumphs of our ancestors. The Ice Age may be over for now, but its story continues. In every glacier that remains, in every fossil we discover, in every question we ask about our planet's past and future, and perhaps most importantly, in the choices we make today. Choices that will determine what kind of world we leave for future generations. A world shaped by the lessons of the past, and by our actions in the present. The Ice Age explained, a testament to the power of nature, the resilience of life, and the endless wonder of our planet's history.